So the two triangles, triangle ABC and triangle DEF, are congruent. What we want to know is segment AC, so this segment here, is it going to be congruent to segment DF, this segment right over here? And further, how do we know? Well, looking at this, if we look at the order in which these are written, this is our congruency statement. So ABC and DEF are congruent, meaning that point A corresponds to point D, B corresponds with point E, and point C corresponds with point F. So therefore, if A goes with D and C goes with F, well, then that means that segment AC would be congruent to segment DF because they're corresponding pieces. So we can say, yes, point A corresponds with point D, and point C corresponds with point F. That alone is enough to say that those two segments are congruent because they are corresponding segments. And we know that corresponding parts of congruent triangles will always be congruent. All right, so today we're going to be doing 3.2, proving triangles congruent. Our learning targets today are I can prove two triangles are congruent by SSS, SAS, and ASA. Now, these will be very important for us. And the important part here for us is to remember that S will stand for side, and A will stand for angle. So this is side, side, side. This is side, angle, side. And this is angle, side, angle. And when we're talking about sides and angles today, I'm talking about the sides and angles within triangles themselves. So we're going to be working with those specifically. So when we covered our last video, we needed 6 pieces to prove that two triangles were congruent. We needed 3 angles, and we needed 3 sides. So we needed 6 entire pieces. Today, we're going to shorten that from needing all 6 pieces to just needing 3 pieces total. And those deal with these 3 acronyms. So the first one that we have is SSS, side, side, side. It says that if 3 of the side lengths of any one triangle are congruent to 3 side lengths of another, then the two triangles are congruent. And don't forget, these tick marks show congruency. We also have those for angles, as we'll see in just a bit. So side, side, side just means that 3 sides on one triangle are congruent to 3 sides on another triangle. And if we have that information, if we have those 3 sides that are congruent, that is enough for us to say that these two triangles are congruent to each other. So if we see 3 sides that are congruent in both triangles, I can say that the triangles are congruent. The next one that we have is going to be side, angle, side. So side, angle, side. Now this one's a little bit different. This one includes this angle right here in the middle. Now it's very important that this angle is sandwiched in between the 2 sides. So it goes side, angle, side. And if I look at my picture, my angle is sandwiched in between 2 sides. I can't skip pieces on it. I can't say that this is going to be side, side, angle. Right? So I need to make sure that I'm going in order around my triangle. So it must go side, then I see an angle, and then side. Now, I only state the congruency marks that I see. So if this congruency mark for the angle is not here, it would have been side, side, and I would have been looking for another congruency mark. So you're just reading through your triangle along the perimeter, and you're just reading the congruency marks. If it is side, angle, side, that angle must be in between. Now you may be wondering, do these need to be having the same orientation? No, they can be facing opposite ways. And as long as you're still seeing a side, an angle, and a side that are congruent, we can still say that the two triangles are congruent. We just would need to be careful with our congruency statement. So again, as long as you see a side, an angle, and a side, we can say that those two triangles are congruent. And again, they must be consecutive, meaning one after the other, and they need to have the same order. So keep that in mind as well as you go through. I can't be saying side, side, angle, or anything like that. So just be careful. The last one that we have is going to be angle, side, angle. Now, angle, side, angle, same type of thing. This side length is sandwiched in between two congruent angles. We can see that on the picture. The side length is sandwiched in between two congruent angles. So angle side angle is enough for us to show that two triangles are also congruent. Now, it is very important that you guys memorize all three of these. Side, 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 and angle, side, angle. I mean, it's really important that you guys memorize these, like really important. So make sure that you guys do look through these. Make sure that you know these, because if you know these and you can just read along the side or along the perimeter of your triangles, you'll be able to do these fairly easy. And they're pretty straightforward as well. So make sure that you guys memorize these and you'll be good to go. Now, again, we're just going to be going through what each of these postulates definitions are. So the first one, again, is side, side, side. So if three sides of one triangle, so we have three sides here, are congruent to three sides of another triangle, then that is enough information for us to say that the two triangles are congruent by side, side, side. And this is what would be in your statement in a proof. So the two triangles are congruent, and this would be a reason. Side, 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 angle, side, and angle, side, angle are our reasons for the congruency. The next one that we have is side, angle, side. So if two sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, the two triangles are then congruent. So again, we can see that right here. We have a side, an angle, and then a side, and our angle is sandwiched in between the two congruent sides. So therefore, this would be side, angle, side. I don't know why I put ASA here. This should be side, angle, side. So this is wrong right here. It should be side, angle, side. All right, and our final one is angle, side, angle. So if two triangles, ABC and DEF, so if two triangles have two angles and the included side of one triangle are congruent to the corresponding parts of the other, then the two triangles are congruent by ASA. So here's a couple different examples of how we can draw these. Again, it doesn't matter which angles we choose from or which sides as long as we see congruency. The key is the congruency marks and just going along the edge. I'm not skipping any sides or any angles. I'm just going along the edge reading my congruency. So I see angle congruency, side congruency, angle congruency. So this would be angle, side, angle. Angle, side, angle. And also angle, side, angle. So again, you can see it in each of these triangles. You're just looking for the congruency marks and you're reading along the edge. All right, so those are our three that we need to memorize. Very important that you guys know side, 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 angle, side, and angle, side, angle. I used to come up with different abbreviations for them, but all of them are kind of out of date by now. So the last thing that we want to cover is CPCTC. Now, we talked a little bit about this in our previous video. CPCTC just stands for corresponding parts of congruent triangles are congruent. And this is really important for us because we're going to be using it constantly in this class. Anytime that you prove two triangles are congruent by either side, 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 angle, side, or angle, side, angle, I can say that any other piece within those two triangles are congruent as long as they correspond to each other. Because if I know that the two triangles are congruent, all the corresponding parts within those triangles, all those angles that are corresponding, that relate to one another, all those side lengths that are corresponding that relate to one another, those will all be congruent to each other as well. So let's say that we have these two triangles here, triangle ABC and triangle DEF, and they're congruent by side, angle, side, as we can see. And we can see that very clearly. We have a side, an angle, and a side, and my angle is sandwiched in between. So that's true. Now, I want to know if the other pieces are congruent. Well, we can find that out. We can say that angle E is congruent to angle F by CPCTC, because I know that the two triangles are congruent, so therefore corresponding angles can be congruent. And B and E are both written second, so they are corresponding to each other. I can then also say that CB, segment CB, is congruent to segment FE by CPCTC. Again, BC is the second two letters here, the second and third. And then E and F are the second and third letters, so those are corresponding parts as well. And then lastly, we can also say that angle C is congruent to angle F by CPCTC. Again, these two angles will be congruent if the triangles are congruent. Now looking at this, we have 1, 2, 3 angles and 1, 2, 3 sides for a total of 6 pieces of each triangle being congruent. And that's what we're looking for. If those 6 pieces are congruent, then we're good to go. All right, so let's go ahead and work on some proofs with this. Here's our first proof. I know it's kind of blurry. We're given that segment AD is congruent to CB and segment DC is congruent to segment AB. What we want to prove is angle D is congruent to angle B. Now, it's very important that you guys are drawing on your pictures as you fill out this proof. Pause the video if you need to so that you can write this down, and then we'll be going through it together. All right, so our first statements. Our first statement should always be our given statements. And our given statements are right up here. AD is congruent to CB and DC is congruent to AB. So I can write those and I can draw them at the same time. So we drew AB is congruent to DC and AD is congruent to CB. Now, looking at this, we have 3 choices to choose from. Side, 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 and angle, side, angle. Now, in our actual 2 triangles, because I have this triangle down below, and this triangle up above, we can see that they're split here. What we want to do is we want to determine which of these 3 we can work towards. So looking at these, and we're going to eliminate some of them as we go, angle, side, angle. Well, I only have 2 sides so far. I don't have any angles. So the chance of me finding 2 angles from what's given to us isn't going to happen. So that's out. Side, angle, side. Well, the included angle, the angle that's sandwiched in between, is angle D and angle B. But that's what we're trying to prove. So that won't come until later, like number 5 or so. So while that may be a possible solution down the road, it's not something that we can work towards right now with our third statement. So we don't have any information from here or in our picture to say that these 2 angles are congruent quite yet. So side, angle, side is out. As for side, 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 is there a third side that we can find that is shared by both? Well, yes, our third side for both triangles is AC. So I can say that segment AC is congruent to AC. It's congruent to itself. By which property? Well, that's by the reflexive property. Now at this point, well, side, side, side seems like it'll work because I have a side, and a side, and same on my other triangle. We have 3 sides as well. So therefore I can say triangle ADC is congruent to triangle CBA by side, side, side. Now, again, be very careful with the order in which you write these. The order does matter. So we see that A corresponds with C, D corresponds with B, and A corresponds with C again. So be very careful when you're naming your triangles. The order will matter. And on the test, you should have a question that asks about the congruency statement. That's what this is. This is a congruency statement. So this is what you guys are going to be writing out. So the order will matter for that. If you don't do it in the correct order, you will miss points on it. Lastly, now that the 2 triangles are congruent, I can say that all the corresponding pieces are congruent. So we see that D and B correspond with one another. So therefore we can end our proof and say angle D is congruent to angle B because CPCTC, corresponding parts of congruent triangles, are congruent. With that, our proof is complete. All right, let's try out another one. This time we're given circle C. We're also given that segment BC is congruent to segment CD, and what we're trying to prove is that segment BX is congruent to segment DY. So go ahead and pause the video if you'd like. You can try this one out on your own if you want to. If you get stuck though, let me know. Or go ahead and watch the video and then see where you get stuck. So our first statement is circle C, and BC is congruent to CD. Well, that looks familiar. Looks like what's given to us. So I can just write given. And as I do, I draw in my picture. The next statement, segment CX is congruent to segment CY. Now, if I look at my reason, it says all radii are congruent. So we have a circle here, And in a circle, we know that from the center to the edge of a circle, that will be the same no matter where I draw it from in the circle. So my radius will always be the same distance no matter what. So that's why it says all radii are congruent. So if that's the case, I'm going to go ahead and draw that in my picture. Now, as we can see, we're working closer and closer towards one of our 3 triangle congruencies. So side, 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 angle, side, or angle, side, angle. Now, again, we need to process and determine which one is the most likely that we can use here. Well, looking at it, our goal is to solve that BX, segment BX is congruent to segment DY. So that's our end goal. So we're probably not going to use side, side, side. Probably not. Because if I can prove that these 2 sides are congruent, then I don't need to use triangle congruency because we'd be done. We would have proven our statement. So therefore, side, side, side is out. Whoops. So side, side, side is out. Next, looking at side, angle, side. Well, I have a side, potential angle, and then side. So side, angle, side is something that we may be able to use. Because again, side, this could be an angle that's congruent, maybe, we'll see, and then a side. As for angle, side, angle, well, let's see. I don't have 2 angles, I only have 2 sides. So chances of me using this right now are very slim. I'm going to say we're not going to use this since side, angle, side looks very plausible. So, if we're going to use side, angle, side, we need to prove that these 2 angles are congruent. Well, how can we do that? How can I say that angle BCX is congruent to angle DCY? Well, look at them. They're opposite of crossing lines, which means they're vertical angles. And we know all vertical angles are congruent. So now looking at it, just reading our congruency, we have side, congruent angle, congruent side. So side, angle, side should work. So now we can say triangle BCX is congruent to triangle DCY by side, angle, side. Lastly, if the 2 triangles are congruent, then all the corresponding parts will also be congruent. So I can say that BX is congruent to DY by CPCTC. And with that, this proof is now finished. All right, let's go ahead and continue on to our final proof of the day. Given ray PM bisects angle QPR, and angle PMQ is congruent to angle PMR. Prove that triangle PQM is congruent to triangle PRM. So go ahead and pause the video if you'd like, and you can try this one out on your own. If you do get stuck though, go ahead and watch the video and see where you made a mistake. And also, if you finish, go ahead and check your work, of course. All right, so first off, our first 2 statements should be our given information. Our given information is that PM bisects angle QPR, and that angle PMQ is congruent to angle PMR. And I went ahead and I drew that on my diagram as well as soon as I wrote it in my proof. Now, out of these 2, one of them leads to a dead end where I can't use anything else for it, and the other one allows me to go a little bit further in my proof. Which one is which? Well, statement number 2, these 2 angles being congruent, that's not going to allow me to do anything else with this proof. That just allows me to say, hey, these 2 angles are congruent now. I can't move further with that info. However, ray PM bisecting angle QPR. Bisection tells me that something's occurring. If a ray bisects an angle, it splits it into 2 equal pieces. So therefore, I can say angle QPM is congruent to angle RPM, because if a ray bisects an angle, then it cuts the angle into 2 equal angles. So these 2 angles are equal in measurement because they are being bisected by this ray. Now, again, we're looking towards proving these 2 triangles are congruent. That's our end goal. That's what we're trying to prove, right? That's what we're trying to prove right over here. Whoops. Ignore that for a sec. So let me go ahead and write them all up once again. So, with this, we're trying to determine which one we can use. Now, side, side, side. I don't have any sides currently. It doesn't make sense to use side, 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 because how am I going to prove that all 3 sides are congruent if I don't have one of them? Next, we have side, angle, side. So again, this is insinuating that we have two sides already. We don't have two sides. We only have two angles. Maybe I can say that QM and PM, I don't know. Maybe that'll work. Probably not, but maybe. Then we have angle, side, angle. Well, I have an angle, a potential side, and then another angle. So angle, side, angle is the most common one that we can actually use for this. It's the most useful one. So is there a way for me to show that this middle side length is congruent? And again, we're trying to prove that these two triangles on either side of this middle line here of PM, that these two triangles are congruent. So yes, let's go ahead and use angle, side, angle. Now, if I want to show that PM is congruent to something, well, what's it congruent to? Well, it's shared by both triangles, so it's congruent to itself. So PM is congruent to PM by which property? Well, that's by the reflexive property. So PM is congruent to PM by the reflexive property. Do we now have enough information for angle, side, angle? Absolutely. So we can say triangle PQM is congruent to triangle PRM by angle, side, angle. And with that, this proof is now complete. All right, so that is it for today's lesson on side, 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 angle, side, and angle, side, angle. Make sure that you guys memorize those and practice these because these proofs will keep coming again and again. Your homework is up on Schoology, and if you guys have any questions, please let me know. Thank you guys so much for watching. I hope that you have a great rest of your day, and take care. Thank you.